Hi everyone, I'm going to show you the differences between a linked list and an array and why we use one instead of the other one in some circumstances. Now for your convenience I've just summarized all of it here. Okay, so the first point is that a linked list has dynamic size. What does that mean? Assume I have a linked list over here. Where is my shape gone to? Okay, I'm going to choose a black. Now I'm creating an array. Wonderful. Now my array looks like this: 3 elements, 3 memory blocks. Now they are, once you create an array, it's really difficult to resize it, because assume I can only put 3 values inside of it. If I want to add another one, assume I want to add another one, I can't do that. I know in Python you can do it. It's quite simple. I think in JavaScript you can also do it, but C++ you cannot do it. It's also considered a low level language. Not that low, but relative to Python. So you can't do that. What you'd want to do is you want to maybe, create another array and dump all of that stuff from here into there. Create an array of 4 elements and dump all of the stuff from the 3 elements array into the 4 elements array, and just at the end append whatever you want to append to it. That's one way of doing it, but it's really inefficient because of the memory allocation. In a linked list, however, you can easily resize the array. Easily. I have a node here. Okay, just let me make it look nice. Now I have an array, or not an array, a linked list, and I link it like that. Okay, of 2 elements, 1 element here, 1 element there. Now I want to add another element. I can simply go ahead and create another memory block inside of memory here, like that, and I can link it like that. Simple as that. In an array, however, I cannot do that. It's fixed. Similar to when you want to delete something. In an array, let me grab my thing. Okay, so in an array, assume I want to delete this one, or I want to delete the last one. You technically cannot do that. There are, however, some fancy algorithms out there where you don't delete the last one. You just write some algorithm where when you are accessing the array, you don't look at the last element. You just don't consider it. You just stop here. Like when you want to put a for loop to print all of the elements inside of an array, you print this, then you print that, then you print that. You don't print that one. Okay, you don't consider it. But if you don't consider it, it does not mean that it's not taking up space in memory. It is taking up space, so that's really inefficient. So that's a problem when you want to delete stuff and insert stuff. You can't really delete the last element. There's fancy algorithms, like assume I want to delete this node right over here. So what I would do is I would take its value, I'd swap it around with the value inside the last node. I'll put its value there, I'll take its value out here, put it in there, swap it around, and then I'm going to delete this one over here. Not delete it, I'm just not going to consider it. It does exist. This does exist, but my fancy algorithm is not going to reach this. That's the way you do it in an array. So enough of arrays. Speaking in terms of linked list, deletion is very easy. Assume I want to delete this block over here. You know how do we do it? There's a link right over here. It's linking to this. What you want to do is you want to break the link between here. Okay, you want to break that link. You want to re-establish another link, but you want to establish it here. Okay, and you want to break this link as well. Now we have a link from the first node to the third node, and in that case this becomes our second node. And since this still exists, we can easily delete it, and then it frees up space in memory, unlike here where you cannot delete it. So that's just some things about linked lists and arrays. Some other thing is that arrays are contiguous, meaning one after the other, just like I said in my previous video. And then of course arrays, you have some wasted space. but a linked list you don't really have wasted space. Remember, here's some wasted space. Once you delete that one, here there's no wasted space because this actually gets deleted. That's that. So that's just some differences.